remind you guys of what this thing up here is. This is a coordinate plane. Okay? A plane in math is a flat surface extending endlessly in all directions. Picture the floor. We've got the hallway, right? So a plane is an idea of a flat surface extending endlessly. When you add axis to it, so there's our plane. When you add an x-axis going across and a y-axis that meets it perpendicular, you divide your plane into 4 sections. We call the sections quadrants. We label the quadrants in a super weird way, of which I have no explanation. We start in the top right left quadrant, and we label it with the Roman numeral 1. And we go backwards. Do you need a pencil? Backwards, counterclockwise.
Oh, it's because the way the word is sorted by
We don't know if that's right, but it's big words.
maybe he was holding it.
I would believe him. So when we label the second one, we go counterclockwise. This one is 2. If you use this when you're talking about a quadrant, you'll be marked wrong. It is a Roman numeral. I don't have a good reason for that, but if you'd like to research it and bring it in, you'll let me know. Bottom left is 3. And bottom right, we write 4 IV. 1 taken away. Okay? Now, to identify a specific spot on our coordinate plane, we use ordered pairs. Ordered pairs always come looking like this, parentheses, x, comma, y. X is the x-coordinate. It tells me where to go on the x-axis. And the y-coordinate here tells me where to go on the y, up or down. That point in the middle where they meet is called the origin. It has an ordered pair of 0, 0. We don't move on the x, we don't move on the y. You have done this many times in your life, probably 5th grade, maybe 4th grade, maybe even younger, right? Plotting points, making pictures.
Yeah.
Today I reintroduced it to you because it starts to relate to what we've been doing with x's and y's. We've been talking about what is, we've been taking tables and determining constant rates to determine if something is constant rate, increasing or decreasing constantly, and if it's proportional, okay? And proportional meaning if you need 2 eggs and 1 cup of milk, and you make the recipe bigger, then use 4 eggs and 2 cups of milk. It increases proportionally. Kind of like how puppies. Did you ever see a puppy with these gigantous paws?
No, my dog is really big, very small.
Well, when they're puppies, sometimes people see these big paws that don't seem proportional to the dog's little body. And you're like, ooh, that dog's going to be a big dog who grows into its paws. Alyssa, are we okay over there? Okay. She's having moments, okay? So when you were younger, and my last class did not have this occurrence, but when you were younger, did your math teacher ever draw kind of like a little math machine?
No.
Okay. And they put a hidden thing in here. Like something's gonna happen in there. And I'm gonna put a number in. Let's say 3. I'm gonna put 3 into my math machine. Okay.
And this was in 4th grade.
Something's gonna happen, and then something comes up. Okay. So let's just say this is 3x. So if I put 3 into my machine, what's gonna come out?
3.
3x.
What's 3x? if x is 3?
9.
9! That means multiply, people. So this is 9, okay?
I don't even know what's happening, but I understand.
So this, what I'm putting into the machine is my x. It is my input. I got to choose it. I could ask Thomas to choose a different input. 5. What will the output be, Kyle? 15, okay? Now, I'm going to tell Isla not to choose an X. Think of it in your head. Think of the X, but don't say it. Can you tell me why? Right? So, the Y depends on what you put in. The output depends on what you put in. So, we call the output dependent because it depends what went in. And since that one's dependent, this is independent. Okay? So you can see that here. The Y, or the output, is dependent, and the X, the input, is independent. If you're independent, you go home after school and no one's home, you get to choose what you're going to have for a snack. You might choose the bowl of fruit your mom cut up for you and left. But you might choose the bowl of Hershey Kisses. You get to choose. That's being independent. That's why the X is something that you choose. Put that in the back and think I
The
can
best chocolate is Oreo.
One that talks to the owls on mini caramel milk chocolate.
Oh, I agree.
All right. So X is always. I like to change the colors. It makes me happy. X is always our independent variable, what we get to choose, and Y is always dependent. So in this case, Mr. Krinkovich uses 13 gallons of gas to drive 250 miles. We want to know which is the input and which is the output. This one's kind of hard because it can go either way, but we can't tell how many gallons of gas he's going to use till we know how far he drove. So in this particular case, the miles are the input or the independent variable, and the gallons are the output, the dependent variable.
Oh, so like independent, you pick the apple, and then the dependent, what happens. So it's like a cause and effect.
Kind of like a cause and effect.
What is the thing that's like
After each apple,
The next one will make more sense. Okay, ready?
Pizza.
So this one makes sense to our lives because we know that when we order pizza, the more toppings we put on, the more cost. Now I order from the Greenfront Apple lot, and it'll tell me like pepperoni's $1, mushrooms is another $1.
White chicken and stuff. So what?
Because subs aren't like that. When you buy a sub at Wegmans,
You can do whatever.
you can put whatever you want on it. It's still going to be $13.50, right? But pizza, for some reason, is different. So you get to choose what?
They get
Toppings.
You get to choose how many toppings. That's the independent variable. That's your X. That's your input into the machine. The cost depends on how many you choose. If I get a plain cheese pizza, it's like $13. If I get the pizza with pepperoni, mushrooms, peppers, and sausage, it's more like $22. Because it's about $2 a topping. You don't put stuff on pizza?
No, I don't get cheese.
Oh, well, I like to get mushrooms and
The best
pepperoni.
pizza is at Perry's, the one,
Barrels.
chicken bacon
Barrels.
ranch or whatever.
Chicken bacon ranch. Look at your new shoes, man. These are cool. You're like a dude.
Anybody challenges you.
Hey, they stay dude.
I mean, yeah.
All right. So, the other thing that I want to tell you. Ready? Right here, this is important. Cost, Gabe, zip. Cost, you need to write that down. Cost is almost always dependent. I can't tell you what something's gonna cost till you tell me what it is you're buying. Right? Right. So cost is almost always your Y dependent variable. Tucker,
What are we doing?
you're just gonna have to jump in and catch up, and I'm recording it, so you can go back and listen to it. And you also have this awesome benefit of a sister that will probably tell you. Okay, now, the grade I get on my test and the number of minutes I spend studying.
That's not true.
Now, this is not always the case. Some kids say, I didn't study at all, I got 98. That's fine. There will come a time in everyone's life when they're going to need to study. I hit mine in college. I went through middle school, high school pretty easily, but I got to college and I was, whoa, I need to learn how to study, right? So, typically, the more time you spend doing homework, studying, staying after school to practice, you're gonna do better. You don't do any homework, typically, you don't have a good grade. I can show you my grade book to prove that to you, like, it's correlated. All right, so, the independent variable, that's totally not what I want.
I got it.
The independent variable, the thing I get to choose is how much time I'm gonna study.
Yeah.
You don't have to study. I can't make you study. I recommend you do your homework, but sometimes I get ignored, okay? What the outcome is your grade. Typically, the more time you put into something, the better you get. That could even be your sport. You don't go to practice, you skip, you put in little effort, you're probably not going to do as well at your sport as if you go home every day, lift weights, practice, pump against the wall. My kids have this thing in the basement where they're throwing lacrosse balls that shake the whole house. It's terrible. But if you don't do it right, you don't get better. So that relates to a sport as well. Little tip right here. Time is almost always independent. You almost always get to choose the amount of time you're going to put into something, right? I'm going to study. I'm going to practice. I'm going to read,
I love you.
right? You don't read the assignment Mrs. Gerstner gives you, you're not going to do well on the quiz the next day, right? So typically time is something, if you need to stop talking, because kids can't hear me because you're talking. Thank you. So time is almost always something you get to choose. Not always. Anyone think of a time when time is not something you choose? Put your hand down and let other people think. Abby. When what? When what? When you're going to an event, maybe if you're running that event, a race is not when you get to choose your time, right? Okay, so running a race is a time when time is not a choice. It's not independent game. A what?
You have to choose
True. They have averages, but yeah, you might run into some turbulence.
or you run out of fuel.
Or God forbid, you run out of fuel and your plane falls out of the sky.
And
And he's always a ray of sunshine.
And it lands in a
He's
river.
just a ray of sunshine. Tucker,
Reading a book.
reading a book, maybe you don't get to choose your time because I'm a slow reader. And I know a lot of people that are fast readers. Not me. Sometimes I have to read the same page several times. Okay.
If you're like
You guys know more about this one than I do. The total number of music downloads Okay? And maybe, I don't know if you download music anymore, but probably games. You download games. Okay? So if you download one game, it's going to cost a certain amount of money. If you download 3 games, the cost is going to be more. So the cost depends on how many downloads. So again, the dependent variable is the cost. Money is almost always dependent. Depends. When you buy it. Okay? The number of tables a waitress serves and the amount of tips that are earned. Slow night, the Tuesday. Nobody goes out to dinner. You wait on 5 tables. You get some tips, right? Friday night, the place is packed. You wait on 50 tables all night. You gonna get more money?
Well,
Yeah, unless they don't tip, blah, blah, blah. But they do. People do. Americans do. Europeans don't. Americans do.
or people can
Yeah, I don't know what it is about Europe, but they consider tipping, they would be offended.
yeah, because
I don't know why. You know why?
waiters and stuff in Europe, waiters in like restaurant people that work at restaurants get like paid way more.
Yeah.
So
So if you tip them, I think they feel like someone left or something, they don't think I'm poor, they're giving me extra money. You know what I mean? So it's just weird in a different culture. So I don't know. Anyway, the number of tables isn't necessarily a choice, but it's what appears that night. And your tips, again, that's money. Money depends on what happened before it. What was the input? 3 tables, a little bit of money. 50 tables, a lot of bit of money. Okay? So you guys have sort of this understanding of input, output, independent, dependent?
barely, but you know.
Oh, well, you missed the beginning. All right. So now we're talking about a red box, which I've never rented from, so I don't understand that either.
So stupid.
Okay? Let's say they charge $1.75 per movie. So we need to know what the independent and dependent variable are. Okay? How many you buy is your
Cost. Independent.
independent. It's your choice. Brock has a busy weekend. He's only going to get 1 movie. Mrs. O'Vanny has no plans for her weekend. She's going to get 10 movies. All right? So we get to choose. So the independent variable is the movie. How many we choose. And the outcome, how much is it going to cost? Okay? That's our Y. Notice I've labeled it X and Y, and I've also labeled it movies and cost. Okay? When I fill these in, 1 movie is $1.75. 2 movies is $1.75 times 2. That's $3.50. 3 movies is $1.75 times 3. That's $5.25. 4 movies is $7. Okay? Now notice, this relates back to our coordinate plane. Because if this is X and this is Y, and coordinates come in the form XY, this becomes something we can plot on a graph. So now everything I'm teaching is almost coming together. So the X axis goes along the bottom. I'm labeling that movies, and I'm spreading that out. The Y axis is the cost. I'm going to label that cost in dollars, and I'm going to spread those out. And then these become points. I'm going to plot 1 movie, $1.75, the green dot. 2 movies, $3.50. 3 movies, $5.25. 4 movies, $7. If I connect those, they create a
Line graph.
straight line, right? If you see a straight line, you know that the cost increased at a constant rate. Increased at a constant rate because it's a straight line. What I'm going to add to that today is to tell you that it's proportional. And it's proportional because there is a straight line and it goes through the origin, the point 0, 0. If I don't rent any movies, I don't pay any money. And this increases at a constant rate proportional. Wow. We've taken what we were learning last week and related it to something we learned in 5th grade, a graph, right? How cool is that? And it's starting to have meaning. It used to be like you plotted points and you made a dinosaur and you colored it in. You needed to do that for today. Because today in 7th grade you're learning that graph has meaning. Okay? All right, so let's take a look at another one. The slowest mammal on Earth is a tree sloth. It moves at a speed of 6 feet per minute. So here's this is Lanny. 1, 2, 3, 4, 5, 6. I'm a fairly slow woman, and I just did that in like 2 seconds. Sloth takes a minute, right? So we want to determine whether the number of the feet the sloth moves is proportional to the number of minutes. So we're going to start with creating a table. Time is almost always dependent. No.
Yeah.
Independent. Let's just say independent. Time is almost always independent. We get to choose the time, usually, unless it's a race, right? So we've got time is our x. We've got a few minutes. Distance is our y. How far did he go? Well, he went for 0 minutes, he went 0 feet. 1 minute, 6 feet. 2 minutes, 12. 3 minutes, 18. 4 minutes, 24. You can tell, I taught you last week, how to tell if this is a constant rate. Does this have a constant rate?
Yes.
Yeah. 6 divided by 1 is 6. 12 divided by 2 is 6. 18 divided by 3 is 6. So it's a constant rate. We know it. Remember that x and y are points that we can put on a grid. X always goes along the bottom. This is our x-axis. Y always goes up the side. And then we can plot those points. Plot 0, 0. Plot 1, 6. Plot 2, 12. Plot 3, 18. Okay? And connect them. What do you get?
Line.
When you're doing it for a section, it really doesn't be a line. Okay. It's a straight line, isn't it, guys? Make sure you label the bottom minutes. Look up here. Make sure you label this minutes down here and feet over here. Otherwise, we don't know what it is. Now, because this graph is a straight line and it passes through the origin, it's proportional. So not only does the sloth move at a constant, steady rate, it's proportional. Okay?
I'm pretty sure that's the toughest the lowest. Are you talking about land mammal?
I don't know.
Where's land mammal?
We're gonna go with it. We're gonna go with land mammals. I don't know.
I'm pretty sure there's a lot of
You can look that up tonight. Let us know. Okay. Now, I want to show you one more that is not proportional. We've got a hot air balloon. It's starting up in the sky at 140 feet, and it descends 20 feet per minute. So we want to determine if the height of the balloon is proportional to the number of minutes. Now, when I create this table, I have to put the 140 over here because I started there. 1 minute goes by, drops 20. 2 minutes go by, drops 20. 3 minutes go by, drops 20. You ever been near the lake, especially in COVID, and these hot air balloons were out and they'd come down and almost touch the water and pop back up? Anyone ever seen that?
Yep.
Cool. Anyone ever been in a hot air balloon?
No, not a death trap.
Me either, and you can't pay me to. You have? You've been inside the balloon? On the ground, and you got to go in it? That's cool. Was it hot in there?
I don't remember.
Oh, you were born.
I don't know what that means.
Okay. Hazel, what I'm looking for, I'm putting it right here. Okay? All right, so I'm gonna label my x-axis minutes. Uh-oh. And my y-axis. But notice the graph, guys. Does it start at the origin?
No.
No. So it is not proportional. Well, on the next page, I only want you to do the front. Are you listening?
Yes.
Do the front of the page. If you were not in class, I'm putting this recording on Schoology. Hazel, you're going to need to listen to this recording so you're caught up, okay? All right.